Hello again. Thank you for joining us on Space Nuts. This is our weekly Q&A edition where we take questions from the audience. We go and find someone who can tell us the answer, and then we pretend we're doing it. My name's Andrew Dunkley, your host. Fred's face went, "Oh, we don't." Coming up on this episode, we've got a lot of solar questions. We've got a question from Andrew about the sun's arc. Ernie wants to know about the sun's siblings, and Mark wants to know about missions to the sun. You go, Mark. I'm not setting foot on it. It's hot enough here already. And we're going to finish off with a question about Earth-like planets. That's all coming up on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
He's back again for more. His name is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Fancy seeing you here.
Yes, it's quite unusual. And we're all decked out in blue today. You've got the gun barrel blue. I've got the sky blue of New South Wales on. That's the official sporting colour of my state.
I didn't know that.
Yeah.
I didn't even know there was
sky blue. Yeah. Oh, look. The official Australian sporting colours are green and gold.
Green and gold, that's right.
But that wasn't actually official until the 80s. Before that, they just used to wear a pair of thongs and a cut-off jeans and go to the Olympics, I think.
She'll be right.
Yeah, mate, no worries. Yes. We've got a bunch of questions to deal with, so we might as well hit the ground running in our thongs. I know there's some people laughing at that because thong means something else in other countries.
It does, that's right.
It's a pair of flip-flops or jandals or whatever you call them, wherever you're from. First question comes from Andrew. It's about the sun's arc. I'm sitting here in the French Alps on Boxing Day, you lucky duck, slightly hungover thanks to an excess of après-ski last night, and watching the sun trace an arc across the sky measured from mountain peak to mountain peak. But why an arc, the shape of which varies by the time of year, given the Earth itself is rotating on only one axis? I know the Earth's tilted from the vertical, but how does that explain the arc? With only one axis of rotation, shouldn't it be a straight line? That comes from Andrew Jones. Hope you had a nice Christmas, Andrew. Sounds like it. What a horrible place to be, the French Alps for Christmas.
Oh, yeah, sounds great, doesn't it?
Yeah. But he brings up an interesting point, sitting there sipping on whatever it is he was drinking and watching the sun and going, hang on a minute. What's going on here? There's an arc. And it's not Noah's.
It's not, that's right. It's a different sort of arc because it's spelled differently. It's got a C instead of a K. In fact, so Andrew's question is, with only one axis of rotation, shouldn't it be a straight line? And the answer is, it is a straight line. Yeah, but it's a straight line on a sphere because our vantage point from Earth. We look out into space. We imagine something called a celestial sphere. It's a great way of, working out the way things move in space and how the motion of the sun and planets all fits together. What you imagine is a sphere of infinite dimensions, and we're sitting at the middle of it. We only see half of it because the other half is below the horizon. It's still there. The celestial sphere goes on below the Earth, this hypothesized sphere. But it's very useful, a useful device for understanding how things move in the sky. And if you imagine yourself sitting in the French Alps with the celestial sphere above you, you would certainly in the Northern Hemisphere be able to see the thing that we call the North Pole Star, Polar Star Polaris, the Pole Star, a faint star that I nearly always look for whenever I'm in the Northern Hemisphere, just to reconnect with it. It's at the end of the little bear's tail, if you know your northern constellations. But that is the... Put it on with us sometime.
Yes, I'll have to.
Yeah, they're great. The northern constellations they've got great charm. Anyway, that's another story. So that is the point about which the whole celestial sphere seems to rotate. And so the height of the pole star above your horizon is the same as your latitude. So if you're at latitude, French Alps is probably 45 or thereabouts, maybe a bit more than that, 45. It means your pole star is going to be 45 degrees above the horizon, and this entire sphere rotates around that point. And so that's why on a sphere, the sun's motion is a straight line. It goes from the eastern side of the sky, depends on the time of year as to exactly where it rises and sets, but it sets on the western side. And so what looks like an arc to you is really a straight line bent by the celestial sphere, this apparent it's just a great way of imagining the sky, because you don't have to worry about the distances of anything. You're just imagining everything projected onto this infinite sphere. And when you do that, as the Earth's rotating, the sun rises in towards the east and sets towards the west. And it follows basically an arc as we see it from our position. But in terms of the sphere itself, it's just going from one side to the other in a straight line.
There you go. Sounds like putting in golf. Like every putt, they say every putt's a straight putt, except that the green isn't dead flat and straight, so the ball will move accordingly.
Yes, that's right. Yeah. In fact, that almost puts you into a different regime, because that's effectively what geodesics are, which are the way light behaves in general relativity. So light travels in what it thinks is a straight line, but it's going through different gravitational fields and gravitational wells. And so like your golf ball when you're putting, it's moving around, it's wandering around.
Yeah. We have a quirk at Dubbo Golf Club where if you want to figure out where the putt goes, just work out which direction the river is.
Yes.
They always fall towards the river.
Always remember, Andrew, that 5 irons don't float.
They do not. It's a good book, that. I don't know who wrote it, but it's a ripper.
I should read it.
Ripper. Well, it's got swearing in it. Don't know how that happened. Yeah, gosh. Disgraceful. And by the way, the French Alps are at 45.8345 degrees north. So you did very well. Yeah. And 6.8655 degrees east. That's right. Yeah. Thank you for the question, Andrew. Great to hear from you. Hope you survived the French Alps adventure. Our next question comes from a new contributor. Hello, Ernie.
Hello, Andrew and Fred. My name is Ernie, and I'm reaching out to you from a small town near Buffalo, New York. I'm a longtime listener, and this is the first time I'm submitting a question. In a recent episode, a listener asked if astronomers have ever identified the star or stars that went supernova, seeding the nebula our sun formed in with heavy elements. This got me to thinking, stars typically form in clusters, and I assume our sun isn't any different. Has there ever been, or is there any active research that is looking for any of the sun's siblings? Thank you so much for doing this podcast. Really enjoy it. Always look forward when new episodes drop. Wishing you the best for the holidays.
Thank you, Ernie. Great to hear from you, a first-time caller-innerer, and great question too. Great question. Sorry to hear about the Buffalo Bills. I don't know if you're into the American football, Ernie, but we visited Buffalo late last year, and they were very, very hopeful that the Bills would come through, but they've been knocked out in the playoffs, so very unfortunate. But maybe next year. They're certainly starting to look like a pretty solid outfit. So, any work going into finding the sun's siblings? Now, I remember us talking some time back about the possibility that the sun had a twin and they got separated at birth and they can't find each other, but they're going through the archives to see if there's any family history that can connect them. But the sun would have been part of, I imagine, a whole bunch of stars that were born in that supernova situation. Is that what he was talking about?
Well, that's part of the issue. The fact that the gas cloud in which the sun and the rest of the cluster that was formed at the same time as the sun, that was seeded by gases from a supernova explosion, which we have no knowledge of. But it's just the background interstellar medium is enriched by the elements that come from a supernova explosion. But no, Ernie's question is on the money, and the answer is yes. That's to try and find the sun's siblings is actually ongoing research, and it's part of the subject that we usually call galactic archaeology. It's looking at the way our galaxy has evolved by studying in detail the chemical composition of the stars within the sun's neighborhood, within a few thousand light years. I was involved with all that with the RAVE project a few years ago. And so one of the, not the holy grails of that, but certainly one of the interesting aspects is to find stars that have identical chemical mixes to the sun. And if you can do that, if you can find them, there's a good chance that they were born from the same dust cloud as the sun was. And so they might very well be solar siblings. It may even be possible that, we know that the sun's 4.5 billion years old, about 4.7 billion years old. If you could look at the motion of stars that have the identical constituents to the sun, and you will be able to certainly measure their velocities quite easily, then you might be able to almost rewind back to a time when you could prove that they were all in the same place at the same time.
Okay. Yeah. All right.
So the answer is yes. There is interest. There is certainly research on all that. And yes, I had a couple of weeks in Buffalo once. I was a guest lecturer at the Canisius College there, and it's very cold.
It wasn't cold while we were there. I mean, it's a stone's throw from Niagara Falls, which
yes, it is.
Like you could almost walk it.
They were pretty icy when we were there.
Yeah. But I really enjoyed spending some time there and learning. Like they had a big exhibition on while we were there about the one of the great canals that was built 150 odd years ago now, I think, and how it changed the entire region forever in terms of trade and movement of materials, and fascinating place, really quite fascinating. Yeah, I suppose the problem with trying to find the sun's siblings is the amount of time that's passed. It's not like you're looking back through your family tree a couple of generations, which we're talking billions of years of movement.
That's right, yes. But as I said, you know, the way you identify them is not because they're close or anything like that. It's by their chemical composition, which we can do out to several thousands of light years, depending on how precise you want it to be. In fact, there's an instrument on the Anglo-Australian telescope, which is called Hermes, which is designed exactly for doing that job. It looks at very limited areas, regions of the spectrum of stars, to look for exactly the amount of chemicals that are in those atmospheres of those stars. And that's the kind of instrument that you use to try and find the sun siblings. What I haven't said is whether there's been any success on that.
I was about to ask.
Yeah. And I can't remember the answer. I mean, there are certainly stars which have got very similar chemical composition and ages to the sun. I'm not sure just how near we are to being able to identify them as definitely coming from the same gas cloud and being born in the same cluster as the sun was.
Well, according to a quick search I've just done, and this is an AI response, yes, astronomers have identified several candidates.
Yeah.
The solar siblings, stars formed from the same gas cloud as our sun 4.5 billion years ago, but none are definitely confirmed.
There you go.
maybe they don't want to be found. Maybe our sun was, the black sheep of the family, and they all went, "No, we're out of here. We know what's going to happen around this place.
It's going to form planets, and then where will we be?
And then there'll be humans, and then
yes, that's right, exactly.
They'll want us to pay them money or something. Yeah, I don't know. But it was a great question, Ernie. Thanks for sending it in, and please do so again. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Hey, that's one of the better sims, believe me. We've had a couple of cardiac arrests down here too, Pete. There wasn't any time for that up here.
Space Nuts.
I love that one. No time for a cardiac arrest. Let's carry on to our next question that comes from Mark. It's another story about this question about the sun. Hi, Andrew and Fred. Are there any plans to send a spacecraft to the sun? And I mean up close and personal. The data they could get would be invaluable and could really tighten up some loose ends on what we think we know. Keep up the great work. That's Mark from Sussex in England. I assume England. I'm pretty sure that'd be right.
Here's how you said. I used to live in Sussex as well.
Yes, yeah, I think you mentioned that a week or two ago. So we've had a few
where the Royal
from Sussex of late.
The Royal Greenwich Observatory used to be. It's a place called Herstmonceux. Yeah, not far from where William the Conqueror landed in 1066.
Okay,
so it was all a very historic place. And the Royal Observatory was
he defeated King Henry.
Harold.
Was it? Harold. I knew it started with an H.
Yeah.
So yeah, look, I know there are probes that are gathering information about the sun all the time, and in fact, we had a recent probe that's name escapes me that actually touched the sun, which was a pretty extraordinary thing.
And in fact, that's the one that really Mark is asking about. Are there any plans to send a spacecraft to the sun? And I mean, up close and personal, it is already there. It's called the Parker Solar Probe. It's flown through the outer corona of the sun, experiencing those very high temperatures. It's got a heat shield. It's in an orbit that is highly elliptical, very elongated. So it spends some of its time close to the sun and some of its time quite a long way away. I'm not actually sure whether it is still active, but what it's done is it has enhanced our understanding of the way the corona is heated. The sun's corona is at several tens of millions of degrees, and the surface of the sun, the photosphere, the bit that we see, is about 5,500 degrees. How does the outer atmosphere get so hot when you've got something relatively cool inside? And the Parker Solar Probe has revealed that it's almost certainly magnetism that does that, the transportation of energy via magnetic fields. You're about to tell me whether it's still going or not.
It is actually. It is fully active. It's healthy. It's operating normally as at early 2026. It's done 26 close approaches to the sun, and that was up to December of last year. And it will continue to orbit the sun. It'll set speed records while it's doing it. It's been doing some extraordinary things. What I find extraordinary is that it can survive temperatures around 2,500 degrees Fahrenheit. That's mighty warm.
Yep, with a cleverly designed heat shield. I think that's what keeps the spacecraft cool and lets it continue its work. It's a very successful mission.
Are there any other probes working out there? I mean, there are observer probes, yes. I believe. Yeah. They're not designed to go in and out of the sun's corona, but they're sort of keeping a close eye on it.
Yeah, that's right. There's so the sun's observed from a safer distance, up close and personal, compared with where we are on Earth. There's a flotilla of observatories looking at the various aspects of the sun. We also now have a very large ground-based telescope that is providing the most amazing images of the sun's photosphere. That's the visible sphere of the sun. It's the Daniel K. Inouye Solar Telescope. It's on top of Haleakala on the island of Maui in the Hawaiian Islands. Marnie and I got married in front of it.
Yeah, I remember. Yeah.
Yeah.
They have great names for stuff in Hawaii, don't they?
Yeah, they do. They do.
Just rolls off the tongue, that one. There are plenty of probes, actually, Mark, that are wandering around the sun. There's the Solar Orbiter, which is an ESA NASA mission, taking high-resolution imagery and gathering data about the sun. There's another one that was launched in 2023, an Indian mission, which is dedicated to observing the solar corona, and it's the Aditya L1 mission. And there's a whole fleet of probes that are monitoring the solar winds. So the Solar Dynamics Observatory, SOHO, that's a famous one. The Stereo mission, because there are twin satellites doing that. I think we talked about that one. Hyneid, which is a JAXA mission. The GOES Solar Ultraviolet Imager, and the Advanced Composition Explorer, or ACE, which is looking at the solar winds, which have been very busy of late. We've seen some incredible activity. The sun's sort of reaching the end of its most active phase, isn't it, Fred?
Yeah, it's sort of still at solar maximum, but it gradually dies away to solar minimum.
Yeah, and from what I understand, you've really only got a short period of time to enjoy the current level of activity before things start to ease off, and we see less spectacular light shows. Would that be the way to describe it?
Yeah, and certainly as the sun's activity declines, the aurora that we see get further and further away from the equator, if I put it that way. The more active the sun is, the lower latitude you can see it at.
Well, it's certainly been spectacular lately. Thanks for the question, Mark.
Roger, you're allowed to start here also.
Space Nuts.
Our final question, or is it a sermon, comes from Martin. Sit back, relax, grab a cup of tea. This is going to take a while.
Hello, Space Nuts. Martin Berman Gorvine here, writer extraordinaire in many genres, with a question for my work in progress, my science fiction novel involving a certain unpleasant, very rich dude called Egon Rusk, who wishes to seed the stars with what he imagines is the master race and comes to a rather unfortunate end. As I've been writing this, their supposed destination is TRAPPIST-1e. Now, Professor John T. Horner mentioned on a recent podcast that all the planets in the TRAPPIST-1 system lack an atmosphere. So I was very concerned about that because I don't want my characters all choking and dying. So I had a look, and it seems, according to NASA, that it's TRAPPIST-1d, as in David, that has been shown to lack an atmosphere, but they're still trying to figure out whether TRAPPIST-1e has one or not. In any case, I was just wondering if there are any other stars with exoplanets within, say, 20, 30, 40 light years of Earth that might conceivably be roughly the mass of Earth and might conceivably have a breathable atmosphere. I mean, this is all kind of off-the-wall satirical sci-fi, so it doesn't matter that much. But I was just wondering about your thoughts. And I don't mean to disparage Professor Horner, but I just suspect that he did see that TRAPPIST-1d lacks an atmosphere and sort of thought, well, maybe that's all the planets in that system. And also, I would like to conclude by reading a poem that I've just written that is a riff on Robert Frost's famous Fire and Ice, about the back and forth debate over the Big Bang versus the Big Crunch, also known as the Gnab-Gib, although I don't love that term because it sort of sounds like a lost BG. So, swell or crunch? Some think the cosmos swells for I, some see a crunch. Of aging bones I know and sigh, so might the cold get worse for I. But pressure hits you like a punch. You feel your skin begin to burn. And so, I have a dreadful hunch. We may all learn. We must all bunch. Berman Gorvine, over and out.
Never leaves you wondering, Martin. Thanks for the question. I'm going to go first here, Fred, because only this morning, by coincidence, did I read a story, and there's a little bit of an irony in this because it comes from the University of Southern Queensland, where Professor Jonty Horner works. And this has been published on the ABC Science website. So it basically says that that astronomers at the University of Southern Queensland have discovered a potential candidate for an Earth-sized planet. It's planet HD 137030b. It's a bit further away than Martin would like, 150 light years from Earth, but it orbits a sun-like star, and they're referring to it as a planet candidate. The paper needs one more observation to confirm the status of planet, but this one is only slightly bigger than Earth, if it is indeed a planet. They think. So an almost Earth-sized planet orbiting a sun-like star sounds like it's got some potential there, coming out of the University of Southern Queensland. So that's interesting news, very interesting timing based on receiving Martin's question just before the publication of that story.
Yeah, and look, Martin's as capable as I am of looking all these up. The Wikipedia list of nearest terrestrial exoplanet candidates is probably the neatest source to go to because it gives references to a lot of the original papers of these, in which the planets are described. It's currently got this is ones within 50 light years. I put in when I went through the search, 34 exoplanets, 11 of which probably lie inside their star's habitable zone. It's a bit more difficult to, as Martin was kind of hinting there, it's a bit more difficult to confirm the atmosphere of an exoplanet, because what you're trying to do is most of these are discovered by the transit method. Planets that go in front of their parent star, they dim the light slightly as they pass in front of the parent star, and you can measure that dimming. But you can also, if you've got very top line equipment like the Webb telescope, you can also look at the spectrum change in the star as the planet passes in front of it, and if that spectrum changes, then you can be sure that the planet has an atmosphere, and you can actually see what gases are actually present in the atmosphere. So that's a much more difficult observation, and I think that's why it's a bit of a struggle for Martin to identify with certainty which of these exoplanets might have an atmosphere. I might leave him to that and remind him that since he's writing fiction, he can do anything like with these planets.
Yes,
anything he wants.
I'm well into my trilogy, Fred. I've written the first book, and I'm 6 chapters into the second book, and still the ideas are still coming. I'm wondering when I'll hit the brick wall, but it's going well at the moment. I'm enjoying it. I'm not going to give anything away, but
you're making it up as you go along.
That's exactly how I'm. Yeah. I'll get to the next chapter and go, okay, where do I want this to go? And I just let my imagination run wild. So that's how I've always written. I don't, started at school doing it that way when I won a composition contest.
Very good.
And that was that. So, yeah, we covered Martin's question. Great poetry, by the way, the big crunch. Yeah, nice work. Thanks, Martin. Good to hear from you. As always, if you'd like to send questions into us, you can do so on our website, spacenutspodcast.com, spacenuts.io. Choose your URL wisely and just click the AMA button, which stands for Ask Me Anything. And that's what we're all about. And don't forget to tell us who you are or where you're from. You can send text or audio questions and plenty of other things to see and do on our website as well. One thing we do ask is if you, it doesn't matter what platform you're on, whether it's YouTube or Spreaker or Apple Podcasts, please leave a review. The more the merrier. They do help, apparently, to find more listeners, and that's what we'd like to do. So if you could leave a review for us, we would appreciate it greatly. And thank you, Fred, as always. It's been great fun.
It's good fun, or else we wouldn't do it.
That's absolutely true. We're certainly not doing it for the money. No. Thanks, Fred.
Yeah.
We'll see you next week.
Time. Yeah.
Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio, who couldn't be with us today because he's actually put his hand up for a mission to the sun because it's a lot cooler there than it is in Australia at the moment. Can't blame him for that. And from me, Andrew Dunkley, thanks for your company. We'll catch you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.